So how do you really build a system that's secure? I don't mean just on paper, but out here, in the messy, real world we all navigate every day. Today, we're going to peel back the layers on the architecture of trust, and we're using 1Password's security design as our map. Let's dive in.
It all starts with a feeling I think we've all had. You install something, a browser extension, maybe an app you think you can trust, and then one day you see this. A warning, the tool you were relying on has been disabled because it's malware. Ugh, that feeling of betrayal, of being exposed, that's the exact problem we're going to unpack.
Because that one little alert, it's really just the tip of the iceberg. We tend to forget that the digital world we live in is, by its very nature, a pretty hostile place. And in an environment like that, even the tools we're supposed to trust can be flipped and used against us. I mean, just think about it for a second. We hand over our most private, most sensitive information to all these apps and services, basically just crossing our fingers that they're doing the right thing. But what's actually going on inside that black box? We're asked to have blind faith, and as we just saw, that faith can get shattered. There has to be a better way to do this. And that better way? Well, it all starts with a totally different philosophy. It's not just about building higher, thicker technical walls. It's about fundamentally rethinking who those walls are for in the first place. And the answer is people, us. So this right here is a crucial idea. Good security doesn't blame you for being human. It doesn't expect you to have a PhD in cryptography. Instead, it starts with the fact that people are part of the system and build security that works with our natural habits, making it feel intuitive, not like some impossible chore. And here's the other half of that same thought. You don't build real trust by hiding how everything works. That's just security through obscurity. No, you build it by putting your designs out there in the open, actually inviting experts to try and break them. Because if your security only works as long as it's a secret, it's not really security at all. It's just a vulnerability waiting to happen. So we've got these two really powerful guiding principles, right? Designed for real, actual people, and be completely transparent about how you're doing it. That's the philosophical foundation. Now let's see how that philosophy gets translated into actual technology. Okay, so the first layer of this whole architecture is something you can actually interact with. The best way to think about it is like a digital safe that needs two totally different keys before it'll even think about opening. Now, the first key is the one we're all familiar with. It's your master password. This is the combination to the lock, you know? It's something you create, something you remember, and it only exists inside your head. But the second key, this is where things get really interesting. This is your secret key. It's an incredibly strong 128-bit secret that's randomly generated right on your device. You don't have to memorize this beast, you just have to keep it safe. This isn't something you know, it's something you have. And here's where you see them work in tandem. Neither one is enough on its own. To get to your data, you need both, the secret that you know and the secret that you hold. This combination makes your end of the security system incredibly strong. But that brings up a really important question. What's protecting your data on their end? This right here is where the architecture becomes truly brilliant. Okay, so we've secured the front door, but what if the entire building gets compromised? What happens if the company itself gets breached? This is the ultimate test for any cloud service, right? If attackers manage to break into the servers and steal absolutely everything, every last byte of user data, what can they actually do with it? Is it game over? The answer lies in this process they call two-secret key derivation, or 2SKD. Now, the single most important part of this whole thing is where it happens, and it happens on your device. That means the final key, the one that can actually decrypt your data, is created locally. It is never, ever sent to the server. Now don't worry, you don't need to understand all the complex math here. Just look at the blueprint. On the left, your password and your secret key go in, and this all happens on your computer. They go through this cryptographic process, and out pops the final key. But here's the crucial part. That final key never leaves your device. The server only ever gets a proof that you have it, not the key itself. And the result of all that is incredibly powerful. It means that even if 1Password servers are totally and completely compromised, all the hackers get is encrypted gibberish. Without your master password and your secret key, which remember they never had in the first place, that stolen data is completely worthless. That, my friends, is the very definition of a zero-knowledge system. So when you put all of these pieces together, the guiding philosophy and the deep technology, it really forces us to take a step back and rethink what trust should even look like in our digital lives. It's really a new model for trust, one that's built on 3 solid pillars. You've got human-centric design, which means security is intuitive. Then you have radical transparency, so you don't have to just trust them blindly. And finally, a zero-knowledge architecture, which means your security doesn't hinge on them being perfect. It's designed to protect you even from them.
And that really brings us to the final question, the one you should take with you. Take a look at the apps and services you use every single day. Are they built for how you actually live your life? Are they open about how they keep you safe? And, maybe most importantly, are you still protected if they have the worst day imaginable? It's a standard of security we should all start demanding.